Good morning. I have this theory that when you give a talk like this, it's best not to prepare it too carefully because it will be spontaneous, so you don't want everything written down and carefully worked out. You want to just relax and be spontaneous. So we'll see. This is my talk. It's a scribbled note of good paper. So we'll see. Testing my theory to destruction. If I seem to be forgetting what to say, it's just I'm being spontaneous. It's not that I've confused myself or forgotten what I was going to say. I never knew what I was going to say. It's usually something like that. So I thought I'd start by finding out what I said I would say. I said I would say this presentation will be the first public showing of APLX version 5. Well, that's true. APLX version 5 is just coming into beta now, and there should be a copy on the memory sticks that came with your conference pack. So we very much welcome your feedback on things I'm going to show, and just have a play and tell us what you think. It also says Richard will be showing some of the intriguing new developments which the APL team have come up with. These include an innovative extension to the object-oriented programming model, some major new facilities in the APLX development environment, and some new twists on old themes. Well, I have no idea what I meant when I wrote that, but let's have a look at APL version 5 and APLX version 5 and see what we come up with. Our philosophy with APLX has been, from the beginning, to make things easy, particularly to make easy things easy. This is the bit of the computing world which always strikes me as missing somehow. Look at Excel or Word or something. A lot of things which really ought to be very easy are much too difficult. Difficult things should be difficult, but easy things should be easy. And the other thing that we try to do is to pick up the theme, I think that's been quite common on some of the talks yesterday, is to give the APLer access to all that stuff up there. There's a fantastic amount of stuff up there that we're not going to get at from APL. And that stuff is things like, obviously, Excel spreadsheets and XML and .NET assemblies and Java assemblies and Ruby programs and R statistics, all this stuff. There's a vast amount of software out there. A lot of it comes free with your existing Windows installation. A lot of it's open source. Simon's talk on R yesterday gave an example. There was many tens of thousands of statistical functions, all written for you, tested, waiting for you to use. All you need is easy access to those functions if you wanted to do statistics. And the same is true in all sorts of other parts of the computing world. So we've tried from the beginning to build not write everything ourselves, but build into APLX access to all that stuff that's out there. That means we put a lot of emphasis on the development environment itself. And one of the things that's come up is when users are used to traditional APL, do they really want to switch to Visual Studio or some of those other things? Because those things aren't easy to use, they're actually quite difficult to use. So we take the view, let's extend the paradigm which the traditional APL is used to, let's add stuff to it to make it nice and simple. Easy to do easy things, but with access to all the more complicated things if you need to do it. Now, one thing that's this is a new twist on the old theme, the first thing I'm going to show you. Performance. Back in the old days, in the 80s and early 90s, whenever we showed a new APL interpreter, the first thing everyone would do was benchmark it, because performance was an absolutely critical factor. Then as we got into the late 90s, past 2000, actually performance became almost a non-issue for most APLs. Not all, but for most. For that, obviously, interpreter writers like to make their APLs perform well, but for most users, they don't really mind whether something takes 10 milliseconds or 20 milliseconds. They don't care. What we've been finding in the last couple of years is, particularly since we introduced our 64-bit version of APLX, we have users who are doing some massive computations with huge amounts of data. When you have an 8 gigabyte workspace, then performance does become an issue again. And one of the things that we've been asked for by our users is some way of profiling their APL code to find out where the performance hotspots are, where the time is being spent. And if you're familiar with Quad AMF in APL Cosmo, I think it is, and Dyalog have something, a similar profiling function, that was something which was missing from APLX. So when people asked us this question about could they profile their code, we would sort of change the subject and sort of talk about something else. But we decided that we really ought to do something about this. So we decided to, one of the new features, this is the new twist on the old theme, is we put some performance profiling into APLX. And let me just show you how this works. Remember what I said, we wanted to make it easy. So we came up with the first design, and we looked at it, and no, too complicated. So finally we decided, let's see if we can get it down to be as simple as possible. Because profiling can be quite a complicated thing. Let me just show you a little workspace which is based on something that we distribute, but don't worry about that. It's just a little workspace which there's a function called run, which is going to run this thing, and and don't worry about the details of this. This is going to run a function. It's actually an object-oriented function, so we're going to create a window, and then we're going to create some objects using quad new. Quad new, the object-oriented extensions to APLX were in version 4. I talked about that last year. Morton talked about object-oriented extensions to Dyalog APL for at least 3 years. So I don't think I'm going to do it again. But that was last year's talk, so I'm not going to talk about that very much. But this is just an example which uses object-oriented programming to create some objects. And what I'm going to do is make a small change to this very quickly, just to so we can see what's going on. We'll run it first of all just to show what it does. What I'm going to do is put a little delay in that. First of all, I'll just show you it running so you can see what this thing is doing. No, that's a little bit too fast. Anyway, what this is doing is each of these things is an object in APL terms. So this is creating thousands and thousands of objects, which are shapes, and they are then being rotated round and moved along to the edge of the window. I'll also do that a bit more slowly. You probably couldn't see what's going on there at all. Okay, that's a bit more obvious what's going on. So each of these is an APL object, and it's being created and then moved around and twisted, and the old one is absorbed and changed. And we're building up more and more, and as you see, they bounce off the edges. And then when the screen gets too full, we're just erasing all the objects again, and we're just rerunning. So let's do that. Let's take out that delay. Okay, now suppose you wanted to find out where the time was being spent in this application. So we're going to profile this application, find out where's the CPU usage high in this application. 3 clicks. First click. Second click. Don't worry about the Dyalog, I'll come back to that in a moment. Third click. Now we'll run the application. You might notice it's slightly slower than it was before. I'm not sure if that's really visible or not. So we'll run the application till it ends. There's your profile. Let me show you what that means. This is a graph showing where the time is spent in that application. So that is saying this wedge here is the line 8 of the draw method in the shape thing took 13.6% of the CPU Line 13 took 13.1%, etc. And then all other functions here took 37.2%.
That's brilliant.
You get a 3D graph if it's multi-core.
26. That's where, and then you can start analysing it. So what we just looked at was the pie chart of where the main time is being spent per line. This is the same thing looked at from macro level in functions. So what this is saying is 55% of the time is spent in the draw, the whole of the draw function, and so on. Now, you can then drill down. Actually, the graphs are all very nice, but what you probably want to look at is things like this, which you may not be able to see very well. But this is much more detail. This is showing us that the same information, but just the basic. So this is saying that line 8 of shape dot, the draw method of the shape object, and that's the actual line, was called 10,656 times. It took 13.6% of the CPU time itself. And then that's actually the lowest level function. If you look at a line such as that one, shape list dot update, for example. So demo line 47 is calling this function. That spent only 0.4959% of the time in itself, but in the functions called from it took 12%. So you can find out exactly where the time is being spent. And you can also analyse the things like chord shape. I won't go through the details of this, but you can actually drill down from a function with the details before. So that allows the APL user to find out very easily where the time is being spent. If you want to do something more fancy, we have a quad function called the quad profile, which allows you much more detailed control. You can switch it on and off and look at individual parts of the application. But we reckon most people will actually probably just be able to use that. Well, yeah.
Does this deal with applications that dynamically generate code as they run pasted in from the file?
It does, yes. Yes, it does.
Yes, what it does is, if it's functions which are being fixed and then deleted again, it would just record the information. It wouldn't have to line the text, the actual line is available anymore. But it would say function thread deleted took however much time.
The interesting thing about this is, if I run this exact same demonstration on my machine at home, sorry, back on my office rather, on my desk, which is a Vista, some Dell machine running Vista, this is Portal running Vista, I get very different results because the top 4 lines here, either 4 lines of code which took most time, are all calling the draw method, which is actually drawing of the thing. If I run the same profile on a different machine, those take almost no time, and the reason is that the machine on my desk has got a graphics accelerator, which means that is off the CPU. So you get very different results. So this is what we just looked at was the whole of the execution time for that aggregator process. What we can do is rerun that, and this time let's say this is going to require one more click. In this dialog, it's giving us a set of options which you probably won't be able to read, but the default there was the CPU cycles used by the APLX application. Modern processors have a built-in CPU cycle counter, so they have a very, very accurate count of exactly how much process time is being used. Vista provides access to that. Older versions of Windows and some other operating systems don't. So that may not always be available, in which case you can go down to straight process of time, which is less accurate. I think this is what I'm going to do here is, rather than asking for the CPU cycles used by the APL application, the whole application, I'm going to ask for the CPU cycles of just that thread, just the APL task. So without the use of GUI stuff, which is done on a different thread. So let's do that. Let's rerun our profile. So, I need to talk whilst it's doing this. So here's well, anyone got a question whilst it's doing that? Okay, not going to take very long. Okay, so we come up with the same thing again. And what we find is now that the worst offender, the line which took the most time in the actual APL code itself, was this line 5 of the rotate thing, which is and the reason it took a lot of time, it's a concatenation, the reason it took a lot of time is it's called 100,000 times. So that indicates that maybe you could gain some advantage by perhaps arranging to call it less frequently or pre-store some results or something. Another one here is quite interesting. That took 18% of just the APL CPU cycles. This inner product took 6%, so it looks like we'll be talking to Roger about optimizing inner product a bit more. But what we hope is that users will use this information both to tune their own code, but also to give us feedback as to how we can improve the interpreter. Of course, if they want to give us feedback, they need to be able to send us something. So what we thought it would be useful to do would be to provide a report facility. So what I'll do is I'll save that. It gives you an APL generated an HTML page, which is all that information we were just looking at, nicely formatted, so you can save it and you can drill down on the HTML page and see exactly what's happening. So that gives us a nice format for saving the information that we've just found there. Okay, that was our new twist on the whole theme. Anyone got any questions?
Very nice.
Very
nice.
Thank you. All I did was insist that it should be no more than 3 clicks. Okay. Okay, so another thing on the user interface side of it is we've added a facility for doing comparisons of building file compare systems that you get in standard editors. So that workspace I was just looking at was a variant of a workspace we actually distribute with our APL systems. And so I thought it would be nice if you could just take your workspace, so I've got that workspace in memory, and choose a it's actually one of our release ones, so it's only so this is saying I want to compare the old version of that workspace that was released with the APL, and compare that with the version that we've got in memory at the moment of our local workspace. So what this is doing is it's looked at all the functions and classes of objects in the workspace, and it said there's a new function that's appeared in the destination workspace, which is this run function that I just ran, the original. And then there's these other functions which are different, just two, and there's a system variable which is different as well. So we can do the kind of thing that you would expect to do in Visual Studio, take the two versions of the functions and just compare them, so you can say, okay, I want to select each difference and either go back to the old version or maybe not go back to the old version and so on. So a nice facility which we felt was missing from those APLs, certain commands. The other thing we thought was would be nice to do was to, and this really is a new twist on our old theme. One of the things about APL, of course, is to do with reusing little snippets of code, little idioms, and the prime example of that is the APL idiom library. So we've put in a nice feature there which allows you to collect idioms together, search them and so on. So, and the APL people have kindly allowed us to distribute that with the APL. So if you want, for example, to know about how you can process dates in the APL in the Fin APL libraries, then you can search them very easily. Just a nice thing for snippets of information. And the other thing you can do is this thing, which we call text cuttings, which are just little snippets of code or functions or text, whatever you like, just to have a convenient place to put them. And this turns out actually to be really rather useful. Let me show you an example. So, for example, here I've got a snippet I'm going to save, which is just a line of code which I want to use for this talk. So it's convenient to put it in here. Let me clear the window. So this is just a little bit of code which just creates an array, a vector of like a pulse, a sine wave going along. So I'll show you what it looks like. It looks like that. So this is a little pulse sine wave. So what we can do is, I'll leave that for a moment. Let's shift it along 2 units, and let's display it again. So as you can see, the original version, the center was there, we've now shifted a little bit to the left. One of the things that people have asked for is what you might call live charting. So we have quite good charting facilities in APL, just either like that, or through a system function called quad chart, or through chart object, which you can embed in your applications. What you might want to do is see how this thing changes. So let's get back to that. What you can do is you can say, okay, I want to. What you would normally do is just say quad chart pulse, and that gives you one graph. What we've done is we've added a new feature, which is a left argument. So say I want to identify the window. I want to remember that this chart has the ID of 1. Okay. Nothing's changed so far. So now what we're going to do is we're going to say pulse is so we're going to shift it along a bit. And what happens now is probably saw it just shifted very slightly in the background there. We've recharted it in the same window. So this is quite fun because what you can now do is you can say oops. Okay, so what we now have got is, I think that must be the shortest code fragment that's ever going to get you background colour display. Okay, so let's just interrupt that. Oh, and the other thing is, we also added a new feature which is users have requested a lot, which is the ability to. We've always had the ability to save these charts and also any graphs you create yourself in various formats. But one format that was missing was high quality formats, which are severe bitmaps or meta files. We've now added SVG, scalable vector graphics. So I can save that graph. Let's call it my graph. Let's save it in. And I can now go to something else like web browser, for example, and and so I get a very high quality, in fact, this is production quality graph from the SVG, which is a very nice feature. Okay, that's some sort of user interface type things and the independent environment type things. We finally got round to some language features which we really should have done a while back. I won't spend a lot of time on these, but so we finally got round to the code missing here. A few more codes. Okay, so intersection and union and unique and stuff we didn't have before. We were sort of waiting for IBM to get around to implementing these so that we could make sure we were compatible with them, but I don't think they're ever going to do any of that. So we've done unique, intersection and union, and we've also done the left and right parsing and stop, which are quite handy.
Do you have exclude tilde?
Yeah, and we always had tilde. Tilde was always there because IBM had it. For some reason, IBM didn't have the others. I've never understood why. But they're all there now, and they're quite fast because they use hash tables too.
Can you do one with repeated items in the right argument?
Sorry?
The unit repeat an item in the right argument. Add this. Or intersetting.
Can I do on the union or the... Sorry, is that what you mean?
Which intersection?
Unions. Or union. No.
I think it's the same as yours, certainly.
So that's a serious question. Did you attempt to make it the same as?
Yes, we did.
Yeah.
I mean, our general approach, if we do introduce any new feature, our general approach is to try to be compatible with what's there, provided it makes sense. Provided it also makes sense. So we actually do hope that's absolutely key thing.
Can you do 1, 2, 3?
1, 2, 3. Yeah.
Union. 2, 2, 4, 4.
Right answer?
Yes. Well, the same answer.
Yes.
The right answer.
But we did consider implementing the tax. The major problem is what's called. Did we resolve that?
No, that isn't resolved.
We have a thing called. We can bring up, as AJ was showing. This is a thing whereby you can just use this as a quick keyboard. And that includes the names. You can just hover, and you can also right-click and get help and so on. So we call them, slot them left and pass them right.
Okay. The reason I said it is the APL standard and the Unicode standard.
Yes.
Name them differently.
Yeah.
Did you choose the Unicode?
For the actual for the symbols or the
the glyphs.
Yes, the long
names in
yeah.
the Unicode and the APL standard.
Can't remember which we
But maybe you don't need to name the glyphs in your documentation.
Well, exactly. We try to gloss over that. Yes. It is actually in our documentation in the character set. Okay. Formula standards called XML. We were talking yesterday about a lot about XML. XML is a funny thing. It has the highest ratio of jargon to content I've ever seen. But, you can read the entire book on XML and not the slightest clue about what actually it is we're talking about. But when you look at examples, it's much simpler. Let's bring up Firefox again. And I'm not going to spend a lot of time on this because it's really quite boring. Somewhere on here, there's a yes. There's an XML file. This is just a sample. It was there yesterday. Server's not working anymore. Okay, it doesn't matter. I've got a copy of it. Somewhere. In fact, I've got a copy on this. Let's just have a look. Okay, this is a little XML file that I just got from that website, which is classic XML. It's actually some kind of genealogy. There is some kind of standard, some schema. And what it is, it's about the Kennedy family. And it's got, so this is a record, reference number 1, name John Fisher Kennedy, sex male, the date of record was last changed, date of birth, and so on. It's a typical XML thing. And what we've done is we've added a system function called quad XML, which was developed in collaboration with Dyalog, who are also doing the same, using exactly the same specification. So hopefully we should be 100% compatible. And what it does is it takes out some of the work, not all the work, but some of the work involved in reading these things, because this kind of thing is actually very difficult to parse in APL. It's intrinsically a nasty problem in APL, because it's all state. You have to go down recursively through this thing, and it's not really a natural APL type of thing. So with Quad XML, I can what's that file called? What I'll do is I'll read that into XML. I'm going to do something pretty sneaky here. I'm going to put the text on the end, for reasons which you'll see in a minute. But perhaps it's easier, maybe it's easier. You can get very, probably the same, doesn't probably matter actually, put it in there.
You've got one more slash.
Yeah, it seems to work. Okay, so so what that has done is it's taken that XML thing and it has decoded it into an array, which is a straightforward rectangular array with a nesting level on the left, tags here, and then the actual data fields there. And there's a whole lot more complexity in this, which I won't go into. Just really to say that one thing that we want to do is to make sure that APL can very easily talk with XML arrays, and also my personal ambition is I would like in the future, when we save workspaces, have the option of saving the whole workspace as an XML data structure. That's something in the future. I've been trying to get my friends at Dyalog to agree to a standard for this, but showing some resistance. But what this does do, it does mean you can do things like, very simply, do things like, right. Actually, I'm going to give this up because you know what we can do with that kind of thing. I want to talk about something else. We saw yesterday the R talk that Simon did on R. One of our design goals with APLX version 4 was to make it very easy to use software, object-oriented software in lots of other languages. So you can create your own APL classes and your own APL objects, as you can in Dyalog and some other terms. You can also very easily use .NET classes, Java classes, and Ruby classes, and now R, the R system, using exactly the same syntax for all those different environments. So, for example, I can say I want to get a date which is and that is now created a reference to a .NET object, so I can use it and display it. I can ask for its methods, and so on. So very, very easy to use the .NET object. Very easy to use your own. We can define our own classes. I can define a class, for example. Suppose you were doing an accounting system, you might have a class which represented an accounting document. So let's create a document. And let's just create a couple of properties. Title, for example. Customer. No, that's right, not the customer. Serial number of the document. And that is going to be initially a scalar. And we are going to say that is going to be we'll leave it public, and we'll say it is a class-wide variable. There's only one copy in the whole class. Oh, and then let's have a constructor on that class. Constructor. And that class is going to bump up the serial number. So we've created a class there. Let's use it. Okay, so we've got a class with the static standard object-oriented stuff. Now, then, if you're used to object-oriented programming or talks about object-oriented programming, you get lots of diagrams like this. They say there's going to be an invoice class, and there's going to be a purchase order class, and those are each going to descend from, inherit from a document class, and maybe it'll be a credit note class. And object-oriented programmers spend most of their life drawing diagrams like this. And the reason they do that is because it is such a pain in the backside to change a piece of the inheritance on object-oriented programs. If you don't get it right, it's a real nuisance. Now, of course, in APLX, that's not really the case. We can dynamically redefine all these relationships at any time. Nonetheless, getting your class hierarchy right is an important thing. One of the restrictions we had when we enabled APLX version 4 was we only allowed single inheritance. So you could only, each class could only inherit one parent. So obviously there could be a whole hierarchy of grandparents and things, but you couldn't simultaneously, if you had another class over here which is inherited from here, you couldn't simultaneously inherit across in two directions. What we've done is we added a new feature called mixins, which is loosely based on an idea in Python. And the way it works is you can still have the same basic structure, but you can dynamically mix in another class to an object. So if I define a class called suppose you had a system like this, and you wanted to have a class which kept track of what's going on. So you might have an audit trail. So it inherits from nothing, and it has a little method called log. And all that log does, in a real application, it will write to a database or a file or something. All we're going to do is we're just going to write to the session. So I can now create a log object. And I can say, oops, log can maybe name. And that's going to just write to the audit trail. Okay. So what we can now do is we can say, okay, actually what I'm going to do is I'm going to change my document class. So in the constructor, it mixes in the audit log.
Quad mixing?
Sorry? Quad mixing.
Quad mixing.
Yeah. So now what happens is that doc3 has got has picked up, as well as what we had before, has picked up a new methods from this class that we've incorporated into the so you can, it's like a dynamic model inheritance. You can do it at any time. I can mix a new class into an existing object. It may have nothing to do with it. What it means is all the methods and properties of the mixed-in thing become available to the class. So you can actually have a dynamic model inheritance. And what you can then do is you can then overload. You can replace the base class method with your own version of it. It's doing a bit fancier because this audit log isn't very clever at the moment. Let's add a constructor. And what we're going to do is we're going to mix in a class written in Java. Java.util.
Do you mean called QuickSym?
Yes, you're quite right. Oh, thank you.
That runs the constructor then, the thing being mixed in.
Sorry?
Will that run the constructor in the thing being mixed in?
It will, yes. And in the case of Java, they got something right, which .NET and Microsoft got very wrong, which is the date object in Java very sensibly defaults to the current date time when you create a new one. .NET one, you have to go this bizarre thing of calling the now class of itself in order to get the current date time. It can be bonkers. So this APL class called audit log now has as well as the log function which we wrote, it's also picked up all this other stuff from Java. So we've now inherited from the Java date class our own all the things that the Java date class can do, and that means that we can rather niftily edit the audit log class again. There's a nice feature in Java, in the Java date class, which is you can do it knows about time zones, so you can timestamp all your data with the actual with a GNT timestamp. Oops. Might be wrong there. Oh, have I got? I don't know.
I didn't think about this last time.
Yeah. No, I've done all that. Okay. So. What did I call it? Let's create a new one, so I can't remember what I called the last one. Sorry. This would be possible being spontaneous. Okay. Dot one. Dot two. Dot two. So we're now able to fairly seamlessly mix in APL classes, .NET classes, Ruby classes, whatever you like, even the whole YAR statistical system you really want to be able to into your APL classes, which it's a nice, I think a very nice object-oriented extension. I think I'm pretty much out of time there. There's lots of other new stuff. There's a document on the in the installation which has got all the descriptions of all the new stuff that's in there. Yeah, any questions?
If you've got duplicate names in the files that you mix in,
Yeah.
do they overwrite what's there already, or do they sort of push into the background what's there? So if you, is there a mix?
You
now?
can do. It'll search in the top level first, and then if it doesn't find it, it'll search down the hierarchy of mixins. So it effectively overrides the. But you can directly call the one underneath by qualifying.
Can the mixed in object, can it see?
No,
It can't. It does has no idea it's being mixed in.
no, it's not virtual. It's not a virtual.
Does one XML write out nested arrays into Nabavi?
So, sorry, can I just ask? Sorry, that's true. That's not true. What I just said is wrong for internal APL defined classes. It would get the top one.
So they can override.
Yeah. It's only for external worlds. .NET and Java doesn't know that it's been mixed in. Yes, you're you.
Okay.
Sorry. Yes. Sorry.
Well, can you write out if you have variables from the workspace as XML using XML?
Yeah.
It's self-invert. It's self-invert. You give it the array and produce it.
Does it preserve comments?
What XML?
As an option, yes.
I remember it.
Hang on, are we talking about XML comments?
Yes.
Yes, when you read it in, use the options of preserving things like white space, which would normally be stripped out, that's not important, and comments and certain types of markup. And when you regenerate it, as Morten says, it's a round trip.
It was jointly developed with Dyalog, so if you think there's any problems with it,
Okay, Richard, thanks very much indeed.